Hi everyone, my name is Ömer Çolakoğlu, and today I will talk about the query optimization techniques about improving SQL Server query performance. And this is a very special day for me, I said, because this is my first international presentation. I'm very excited and I'm very happy. But first, I want to apologize my poor English. I will try to use basic words and sentences. I hope you will understand me easily, and I hope you won't be bored. And I want to special thanks to San Diego SQL Server Group and Eric and Rebecca for accepting my submission. I'm very glad to be here. I wish next time maybe we will be together as face-to-face. I will be very glad. So, yes, let's start. The SQL Server is really skillful software, and the main point is to know how SQL Server engine works. Yes, it is really the main point. So the SQL, the SQL is the global language for all databases, but T-SQL is the native language of SQL Server. You can query any database with SQL, but with T-SQL is like a programming language. You can program your database system. So if you are good at T-SQL, yes, you can rocket your slow queries even 100 times or 1,000 times more. These are real numbers. These are real multiple values, because every day I am using these techniques and improving the performance of the database. And let me introduce myself. I have more than one hat. I'm from Turkey, and I am a data platform MVP with 4 rings. 4 rings because this is 2 weeks ago, I got my 4th. I have 21 years experience with SQL Server. I am also IT manager of a private company in Turkey, and I am an instructor and trainer on some online education platforms such as Udemy for 8 years. I know that it is too difficult to believe, but it is real. I have more than 300,000 of students in these platforms with SQL Server courses. And I am a community lover like Eric and Rebecca. Okay, this is Ömer Çolakoğlu. And these are my contact info. If you want to get in touch, you can use any of these. Let's look at the desk in front of us and check what we have. Today, everything is changing so fast. We have some topics, for example, Azure, Fabric, AI, Copilot, ORM tools, data science, Power BI, Synapse, etc. A lot of subjects changing day by day, and it's changing so fast. But let me restart my PowerPoint. It's not a problem because, and I'm continuing. So what's the problem? It is just a PowerPoint. We are working at the big data, SQL Server. What is it? It's just a
Windows
PowerPoint.
update and a virus scan.
And let's try it again, this slide. So let's look at the reality. There are lots of new technologies, okay, but let's look at the reality. We have an unchanging concept. The name of the concept is performance. It is always the main subject of the data systems because data is growing so much. The SQL language is the most important skill for data users for more than 50 years. So it's crazy. So if you know SQL and T-SQL so good, you will be happy, even those new technologies and concepts. And you can see in my T-shirt, trust me, I know SQL. Yeah. So next slide. Okay. What does the performance mean? The performance mean for the end users, the performance means the sequence which shows so fast, and we can say that the query duration is a measure, but not only think about the performance. As DBAs and DB developers, we have to check other values for the performance, such as read and written, page count, memory usage, CPU usage, etc. So these sections are defining the performance for us. So you will see some wise sentences at the left bottom of the screen like this. There is no absolute rule in SQL Server. There are always a benefit cost ratio, calculations, options, and choices. These sentences belong to me, and I think it will help you to understand the SQL Server philosophy, and I call it SQLism. I think you will like this sentences. Okay, let's talk about how can we improve the SQL Server performance. Here is the flow: measure and check, determine the problem, develop a solution, try and fix. It's very simple. And then what we need, let me try the full screen again. Okay, here is another sentence. Performance optimization is like a matryoshka. The biggest problem is in the smallest egg. So what we need: index management, query optimization, system configuration, to have knowledge about the SQL Server objects. Today, I won't talk about the system configurations, but I will talk and some demonstration about the other sections.
Omar, what's a matryoshka?
Matryoshka, you don't know matryoshka? Let me show you it like you.
Google it.
Does anybody else know what matryoshka is? Or is it just me?
No.
I have no idea what it is. Oh,
We call that Russian doll.
Yeah, Russian doll. Yeah, that here is the problem. Yeah, the sentence. Performance optimization is
the
like a
smallest.
matryoshka. The biggest problem is in the smallest egg. So
Yeah.
you have to get out the eggs by one.
Makes sense. Thank you.
I'm okay. I'm going to continue. So let's talk. Let's underline the index management topic. For example, it is very important in SQL Server performance. We have some questions. For example, the first question is: do we have to use or should we use the clustered index? Yes, actually, we can say that we should, because clustered index means the physical allocation of the data, and another index is reference to this index. And other question, we should use clustered index. What data type should we choose? Actually, we use the identity integer or global unique identifier data types. I think the identity integer value is more effective than the global unique identifier. Actually, it depends on your data scenario, such as if you use the microservice architecture, you should use the global unique identifier. But for the other scenarios, the identity integer has advantages better than the global unique identifier. By using identity field as clustered index, you guarantee no fragmentation, because every new row is written to the end of the data, so the order will never broken. On the other hand, the other question is how to order the composite indexes. For example, we have a query, and we have 4 conditions at our where clause. For example, where name surname like David and birth date equal 1987 and state equal Arizona and city equal Phoenix. For this query, which index we should use? And if we use the composite indexes, what is the order of the fields? For example, we have 4 condition here. And, the order can be like this: state, city, name, or city, name, birth date, or state, or 24 different options. It's the basic of math formula. It's 4 factorial, and we can order this 4 fields 24 different options. And I will answer for this case in my demonstration. So let's break here. And the other question is composite index or included column. Our aim is to increase page read. So we want to read just index pages, not data pages, and don't want to do KLOOKUP. For example, select ID, name, surname, birth date, city from customers, where name, surname equal David Farrell. Where we have an index, the name, surname column, but we want to select the other fields, ID, name, surname, birth date, and city columns too. So then we have two options. A composite index with the union of ID, name, surname, birth date, city fields. The other options is an index with name, surname, field, and including data, including the field ID, birth date, city fields. So we can choose the second option. The index has the included columns because we don't need any order operation with the column included columns, and this option is more efficient than the first one. So for this scenario, we can choose the included column. Other option is about the indexes, the column store index. Any one of you using column store index?
Andre. Yep.
Are you happy with the column store indexes?
Yeah. They're great for reads. I'll say that.
Same here. We don't use it too much. For very specific tables, we use column store.
Okay. Are you using it the data warehouse systems or real database?
Data warehouse.
Data warehouse. Are you using clustered column store index or just column store index? Clustered. I think column store in clustered column store index is the wonder of the database world. But most of the people don't know this type of index. If you are using the data warehouse and if you are using some business intelligence tools, you can use it so easily, and it is so skillful. And I definitely advise to try the column store index. And if we have time, I have a demo with 50 million rows of data with the clustered column store index, and we can see the performance. Okay, these are my query performance tips, and let's talk about some of them, and let's show some demonstration, some of them. Don't use union. I see the union word lots of environments, especially in views. I can just say that it is a real performance killer. We can use the alternatively temp table and store procedures. We can insert data from different tables or queries to temp table instead of the union or union all. So it's a natural alternative to union. I definitely advise you to avoid using union and union all. And don't use views in UDFs. Views are so useful objects. We know they can simplify the query and architecture because we know that the lots of joins, the queries with, for example, 10 joins are not easily readable. But a view is very readable, even a new worker or new stuff. I see these are useful, but this gives us a bad habit for using views everywhere because they make us lazier. We start to views in user-defined functions. It's very bad idea. We join views each other and create a new view. And we have view, and inside of the view, we have some joins, and joins are other views. It is a very bad idea because it's a very complex for the SQL Server. And I will repeat this sentence much more during this presentation. SQL Server loves the simplicity, and then make your queries simple. I just want to say that the views and using views in views and joining views and using views in user-defined functions, these are really performance killers. And if you are using views like this, yes, you are the murderer of your database. So please use raw queries in user-defined functions. Okay, next tip, if you need, use force index. Sometimes SQL Server cannot find the right index for the query. You have the right index, but SQL Server cannot find. It choose the wrong index. A lot of things can be caused to this case, but I can say that don't waste time trying to find out why. If you trust your index, yes, you can use force index with hint. Next tip, avoid distinct and count in big tables. And also, I see distinct words in lots of places. When I ask the developer, why are you using the distinct command? The answer is, sometimes I'm getting repeating rows with my queries, and I want to make sure that my rows do not repeat. I'm asking again, you write more than 100 queries, and maybe just 2 or 3 one has repeating rows. But you write distinct words for your all queries. It's crazy. And if your query includes repeating rows, and it's a problem for you, then you must find the reason of the repeating, and you must solve this problem. The distinct mustn't be your solution, because the distinct is an extra process for the result. And yes, the cost of the distinct is very much. And it is a real performance killer too. And you want to learn about the row count in a table. Everybody use select count star from table name. But if your table is a big table, then the count function takes time to get, and the cost is very much. You can use some alternative ways, such as sp space use it, or select star from sys.dmdb partition stats with table name. These are really fast, and I will show you with my demonstration. Don't use function in where condition. This is a very common usage, and I see you everywhere. But it is very bad habit, like the wheel. For example, we have a scenario. You want to select people who born today from 10 million rows. The first technique in most people's brain in using datepart function, because it's very easy. People who born today means I need 2 parameters, month and the day. And I can use datepart function, datepart month, dv. But this way is really disaster, because the system cannot use the indexes and scans all the table. And also this situation is valid for the other functions, such as if left, substring, or any other user-defined function. So I have a demonstration with this case also. After the presentation, I will show a demo, and you can see the cost of this type of query. And check the page you read. The performance indicator is not only duration, but also web page count is very important indicator. What I want to say, or what I mean. For example, you write a bad query, it works, and duration is about 2 seconds. This is a bad query, but duration is 2 seconds. So you can say that this is a fast query, maybe. But if you investigate the page count and you see the reading page about it's 1 gigabyte, then yes, you have a problem. Because reading 1 gigabyte data from the memory can be fast, because 1 gigabyte is not a bigger data for the memory speed. But this theory is valid for just one concurrent user. If you have 50 concurrent users, then you have to read 50 gigabyte data. So yes, you are in trouble. And yes, it won't take 2 seconds, maybe 1 minute. And I have a demo for this situation too. The other things, be careful with the triggers, because they are the natural part of transactions. We can use triggers for some situations after delete, update, or insert. Think about, we have a table delete trigger. It locks the deleted data to another table. It's a basic scenario. Think about this situation. Any field in log table gets an error. Your main table, you don't have a problem, but in your log table, for example, you can get an error like this: division by 0, or string or binary data is truncated. So what happens? The data in the main table will be deleted, and nothing will happen in the log table. 2, the data in main table will be deleted, and you get an error in the log table. And 3, nothing will happen for both tables. Answer is 3. Yes, nothing will happen, because the triggers are the natural part of the transaction. And if you get an error in a transaction, it will automatically roll back. So be careful while writing triggers. Sometimes we will see this scenario. the insert process duration is so long, but the problem is about the trigger. For example, in trigger, you selecting data from a table, and you have an index problem with that. So you just want to insert the data in main table, but it takes so long time because of the trigger. So you should consider these situations while writing triggers. Yeah. Next session, test the UDFs, user-defined functions, individually. User-defined functions can be used in a query as fields, and UDFs runs line by line. So there are two parts of the performance of the user-defined functions. One, the individual performance of the UDFs, and two, row count and working count of the UDFs. If a UDF duration for one row is 1 second, then it takes 1,000 seconds for 1,000 rows. So we can't change the row count. Then we should make the UDFs better, and our main points must be the UDF. I think I have a demonstration for this situation too. And use table valued function instead of the multiple functions. Think about the scenario. We have a product table, an order table, and we want to make some product analyze. We have a few UDFs for product table, which gets product ID as parameter. For example, sale amount, sale total, mean sale price, average cost, average sale price, average profit, etc. We have 1, 2, 3, 4, 5, 6 UDFs for this query. I think using a just single table valued function, we can get these 6 values at the one time is better than the individual UDFs. This is more effective and has better performance. And I said that don't join views. Yes, I talk about this situation. And on the other hand, don't bulk update or delete in big tables. For example, you have a table with 10 million rows, and you have to name, you have name, surname column, and you want to add 2 columns more as name and surname separately, and want to update these columns by splitting name, surname column. If you update these columns as bulk, it takes, if you update these columns as bulk, it takes a lot of time and it locks the table. So other users can't select the data from this table because it's locked. There is another way. You can update all table with a loop and set by set. So according to this scenario, you can update your table by 1,000 rows for each step. With this way, your table will not be locked, and users can select data, and your transaction log file won't grow. So this is a very important tip while bulk update or bulk deleted in your big tables. Do you use linked servers?
I know this is a trap, but yes, I have used them.
Okay. Most important problem about the linked servers are very useful for querying remote data, okay? But we are forgetting something while selecting data from the linked server. We are joining the remote table with our local table and expecting the same performance with the local table join. It is impossible because don't forget, linked server is a remote server. And if you select the data from the linked server with open query or open row set, it doesn't matter. It works with the network speed. It's not RAM speed. So if your data on the remote side is big and row count, you have much more rows, then it causes the low performance. And you must focus to decrease the data coming from the linked server. This is the main point. You shouldn't select the data.
Is it just me, or
are
we getting frozen here?
Sorry?
No, nothing on my end.
Okay. If you have 1 million rows or 10 million rows in table on the remote side, don't use select star from open query or open row set all the table. you can write a store procedure. You must focus to decrease the data coming from the link server, and you can write a store procedure at the link server, and you can exec this to the temp table. So like this way, you get the data just you need, and the most of the process is work at the remote side. And you can use open row set instead of the open query because the open row set is always run at the remote side. But open query sometimes gets all the data, sometimes run at the remote side. It depends on the data. The SQL Server decides this. This is a trick about the link servers. The other trick, prefer store procedures for repeated queries. The store procedures have magic power because the ad-hoc queries are compiled before they work, and it's always recompiled. If you use frequently repeated queries, it can cause a lot of compiling load, and you can see the compilation wait type on your server. If you use store procedure instead of the ad-hoc query, the procedures are compiled just one time, and they run faster because it doesn't waste time by compiling. I have a real-time story about this situation, and after the presentation, I will show the results. I just changed the one ad hoc query to the store procedures, and you can't believe your eyes with the results. Please wait for the demonstration time. Okay, big character limit in varchar. There is a wrong information about varchar and varchar data types. People knows that the varchar data type is useful because the length of the data is short. It takes up less space. If is it short, it takes up more space. Therefore, there is no harm in giving more classes than necessary. So we can use varchar 1000 for name term fields. It is not a good approach because there isn't a limit for using indexes. If your varchar field length is more than 900, you can't use index this column. So the limitation is important. So please define the character length with your requirement. I think the 50 is enough for name term fields. And okay, let's make some demonstration. This is ancient magic book, how to make queries ultra fast. And you know here's the Merlin, and you see the index and content here. Index management, query optimization, magic, server configuration, etc. Birthday query. That's right. Yeah. I have a star from customers. It's the real American names and surname, but the data is not real. It's a fake data generated by me. It's about, I think, 7 million rows. Let's see. Yeah, it's about 7 million rows. Let's drop the indexes. Okay. Set statistics on. And yeah, I want to get the people who born today. Select ID, name, surname, gender, birth date from customers, where date part month, birth date equals 7, and date part day, birth date equal 19. And we have 5,000 rows, and this is the page rate. Yeah, it's this is formula, multiple 8 and division. It's about 3 gigabyte data we are reading from the, but we can say that, so it is fast. Let's try. It is fast, okay, but just one concurrent user. What about the for 15 user? This is my trace, and this is my post stress test. Yes, ID, name, surname, gender, birth date from customers, where date part month equal 7 and date part day equal 19, and 15 repeat 5. It means 50 concurrent users run this query, and I run it. As it's working, the duration is 0. It's milliseconds, and now the duration is 10 seconds. So the duration cannot be a measure for the cannot be only measure for the performance. So we should check the web pages. Is it working? Okay, you can stop. Why is it so slow? Because let's check the execution plan. It can't use any index. Actually, we don't have any index here. Let's create an index. For example, x birth date, birth dates. Now we have an index. Let's check. A little bit decrease it, but it is really so much. And using our index. But the right way, how can we improve this query? We can do this. We can create a date table like this. Let me show you. It's a time series table. I think we have 100 years date table. And we have year, month, day, month name, etc. So we can join these tables. And now we can use the birth date. And let's check the page reads. It is still so much because I didn't use the included columns. And now the read count is about 500. So let's measure the improvement. 600 times faster than the before. Next demonstration, normal index or composite index. Get customers with filter, name, surname, start with David, and birth date is 1987, and state is Arizona, and state city is Phoenix. Okay, let me drop current indexes. Okay. Now the query is like this. Sorry. We have 2 rows, and this is the page count. This means it scans all the table. So we need some indexes, maybe individual or maybe composite indexes. For example, I'm creating these indexes: name, surname, birth date, state, and the city. And I will try these indexes individually, and let me check. For example, first index, name, surname. Let's check. This is really huge number. It is bad. So let's try birth date. This is good, very good. And state, oh, it is very huge. And city, it is very huge again. So we need a composite index. But what should be the order of the fields? Let's check. The name, surname, like David, as the row count is here. And birth date, the row count is here. And the state, Arizona, row count is here. And the customers, city, row count is here. The most important thing is the last row count must be the first order. Because this is the less repeating values. So create index, a composite index, the name, surname, birth date is composite 1, and composite 2. Birthday is the first order, and T, state, name, surname. It's going on. Let's try with the IX composite 1. It's about 600. And let's try the composite 2. It's just 12. So in this query, when we use the composite index, our gain is, I'm dropping all of the indexes. Yeah. We turn the starting point, and our first value is this. And let's check our gain. It's about 30,000 times faster than without indexes. Okay, I'm finishing bulk update. Let's talk about the bulk update. Alter table customers. Okay, alter table customers add name varchar 100 and surname varchar 100. And now I want to update the name surname column with this query, and you know it's a bulk update. Now I run it, and other user changing, other user selecting the data, and it's locked. You can see. So the system is locked. But the alternative way, it's a loop, and I'm using update top 1,000 customers each steps, and I just 10 milliseconds waiting here, delay here. So update is going on, and other users working without any problem. It is valid for the deleting, bulk deleting or bulk inserted. Subquery, join, or UDF, which one we have to choose? I have a data, sorry, Walmart items. I have a table. It contains the Walmart products. Yes, it's about 500,000 rows. And I have a table, order details. It's related with the item ID. And let's check the row count. You see the count function. It takes 2 seconds. Let me show the alternative way. This is an alternative way. Sorry, orders. It takes milliseconds. It's very fast, and it is very slow. So order details like this. It's very fast. Okay, I want to calculate some information about coffee accessories, and let me drop indexes. One way is using subqueries. It is very slow. You see, it takes 10 seconds. And let's try to join. It is very fast. So we can say that join is better than the subquery. Yes, it can be true. But remember that there is no absolute rule in SQL Server. There are always calculations and options. And we can use the functions. For example, get min unit price. So it's a basic function and similar functions. And when we run this query, I think it takes at least 1 hour. So we can say that user-defined functions so bad, don't use. Maybe. Let's create an index because the order detail table, look at this item ID. I create an index for item ID. Let's check now. Now it is really fast, but it takes 1 second. An alternative way, creating a table valued functions, item info. These functions select all information with the other individual function in one time. So let's try it. You can see it is very fast. This is the other demonstration. Yes, I am. Okay, I want to share an interesting demo for you. Full text search. Do you use SQL Server full text search in your environment? Anyone?
Yeah, we do.
Are you glad for the performance?
I can't really tell, to be honest. I don't notice the difference.
Okay.
It's always on.
Okay. Oh, okay. T-SQL is very skillful language, and you can write your own algorithms, full text algorithms. For example, last week, I wrote my own vector search algorithm. You know, the vector search is the newest and fresh subject, and it runs just the Azure SQL, and I can use it on-prem SQL Server with my own algorithm. and I want to use my own full text algorithm to you, I have a tables, Walmart items, for example, and I have ready file full text. This is the legacy surging. It's fast, but my server is fast. Reads is, yes, it's about 40,000 page. We can use the SQL Server full text, but this is my own full text algorithm procedure. It get the cache, and you can see the counts, and also in SQL Server.
I think I might have missed what you just did, Omar. So you said exec search. So
Okay, exact search.
We see the
You can see it's very basic. I will show you. That's all. I can share code with you, but the way is so easy. And what I did, this is the main table, and we have, for example, I think title, item name, which one, product name. Yeah, this is the main field, and I separate this product name. Yeah, I separate these words to a table and insert to a table. For example, ID is 1. Yeah, select star from Walmart items where ID equal 1. This one. Select star from words where string ID equal 1. So this is the main product name. This is the words, and we can use in here indexes, and in my search query, create a dynamic query like this. Let me show you. When I run, sorry, where is it? Okay, close. Text. This is the dynamic query. Oh.
that's an interesting one. I've never seen that done before.
Because I wrote it. It is better than the SQL Server full text search. I want to show the difference. For example, contains like this product name. I think like this. What? Okay. This is before quotes.
I don't think the double quotes are in there, right?
Not contains. I think like this contains and Pepsi and cola, caffeine, etc. So this is the SQL Server full text. This is fast. Okay, we can use that like this. I think I should remove this. I couldn't remember. That's okay. No, Pepsi, cola, caffeine. What is the difference? I didn't remember. I couldn't remember. There is a trick here. We can choose the percent character in here, but we can't use the percent character in here. For example, we can see that we have 24 rows with die, but like this, we have 0. Let's try my algorithm. For example, it's okay. For example, it's okay. For example, it's okay. And it is really fast. I can share the algorithm to you. And I am finishing. I'm sorry. I think we have a little problems. We had a little problems.
No, I think your demos are great. If you got more, I think people are interested in seeing them if you have time.
Yeah, please don't feel rushed, Omar. We'll stick around as long as you can go.
So should I go on?
Sure.
Yep.
Let's look at the legacy times. Our procedure is a real lifesaver, and traditional knowledge is always valuable. says or wise bird. Let's look. It's a real life story. Vehicle GPS tracking system. I have a friend who works and who managed the SQL Server of a company who produced the vehicle GPS tracking system. The system works like this. Lots of cars have GPS modules, and they share their GPS information to the cloud with Web Server 1, Web Server 2, 3, etc. And it is written to the SQL Server database. Let's look at the numbers. We have a vehicle status table, last status table, and this is the sample table. We have about 200,000 vehicles, and we have 200,000 rows in SQL Server. So 200,000 vehicles updates every 10 seconds. It is a huge update. Yeah, it means 20,000 updates per second. So it can cause any performance problems. I'm sorry, this is now daytime, and let me check my camera. How is it going? I don't know, because when we started, it is nighttime.
It is bright now behind you.
Right. Just a second. Let me close my curtain.
Oh, it's automated.
Eric's dream to have automation in his blinds.
Nice.
I think it is better. I'm sorry for the darkness. It's not my fault. Okay, this is the simulation of the system. So we have a problem about the frequently updated table. So this is the profiler. They use ad-hoc queries and updating 200,000 rows vehicle table by ID every 10 seconds. And this is the CPU utilization with 38 cores. It's system working at 90% CPU usage. And the problem is the system is using so much CPU with 38 core. Yes, we can see the matrix 38 core with ad-hoc query, and you can see the CPU usage. And when we look at the resource weights, we see that compilation weights so much. This is the problem, because the ad-hoc queries are compiling every time before they run. I advise that please change it to the store procedure. And let's check the results. Yeah, this is the average usage of CPU, and the average network usage. It's 200 megabit per second. After changing the ad-hoc query, the store procedure, you can see the store procedure here. And be ready. This is the result. This is the CPU usage, 10%. And it's not finished. Remember that we had 38 cores, but this just 20 cores. Yes, the average CPU usage is, you can see here, is 10%. So oldie but goldie, legacy is the best. Store procedure save your lives. And AI, the most popular topics in our lives. And I'm using AI in my SQL Server optimization, query optimization. So you can check these domains, SQL Server.ai and Azure SQL.ai. These are my own domains, and this is my own GPTs at SQL Server. Yeah, by Ömer Çolakoğlu, you can see here. So let's check it. For example, I open my birthday function, birthday query, and I copy here. Hey, buddy, this query is killing me. Tell me why it is so slow. Here is the query. It's produced alternative solutions to me. And can I use time series table with this partition? I think it is not necessary. Time series table, no, I think it's a bad solution. Sorry. Let me share the execution plan with you and tell me an advice. I'm going to here and I think this XML and paste here.
Don't trust it. It's going to hallucinate.
Actually, I use it in Turkish. I can say that Turkish advices are more successful than the English. This is first time I'm trying to English. And in my Twitter account, I'm sharing with my solutions. You can see the scenario here. So, as a summary, you can use your own GPTs, and in here, explore GPTs here. For example, I wrote SQL Server, SQL Server Expert, DB Assistant, like this, and this is my own GPT. So, yeah, be ready to use SQL Server with AI. And I want to thank you for all of you. I talked about the SQLism, and these are my sentences, wise sentences. Write readable queries, not for other developers, but for SQL Server itself, because SQL Server loves simplicity. Think like a SQL Server. There is no absolute rule in SQL Server. There are always a benefit-cost ratio calculations, options, and choices. There is a feature that distinguishes SQL from other coding languages. In order to write good SQL, you must have good analytical thinking skills. As you write more SQL, your analytical thinking skills improve. As you improve, you write better SQL. Two skills that feed each other. Every DB developer and DB admin has magical powers. If you are dealing with a database and don't realize it yet, you are just a young wizard who doesn't know how to use it. Performance optimization is like a matryoshka, you know. This is the matryoshka, yeah. And generally, the biggest problem is in the smallest stack, like the user-defined functions. If you want to have wisdom, then learn query optimization. You will soon realize that you are becoming illuminated. Fastest query is the one that doesn't have to run.
It's deep.
Yeah.
If you optimize a query that takes 50 minutes and reduce it to 1 minute, you can extract approximately 1,000 liters of well water with the energy obtained and save the planet. It's a real information. Yeah.
Oh, yeah.
Yeah.
Cool.
So thank you.
When I feel like I'm saving the world when I optimize a query.
Everybody here are superheroes.
Omar, do you market your shirts, your Trust Me shirts?
This is my design. I can share my design. I'm sorry, I can't send T-shirt to USA, but I can share my design.
Does anybody have Omar? We're going to open up the floor. I'm sorry. Does anybody have any questions for Omar? We're going to go ahead and open up the floor for last minute questions, Q&A.
There's been a lot of great comments written down. Thanking you for your presentation.
There is no question. Is it good thing or bad thing?
Hi, Omar. Thank you for the presentation. I actually do have a question, but it's more related to isolation levels and not query optimization. If it's okay, I'll ask.
Kevin?
All right. So I
Sounds different.
have RCSI enabled on a database. We're experiencing some deadlocks, and I just read an article recently that it could escalate to a serializable query or session. And I'm trying to identify that via T-SQL. I think there was a DMV, but it was very hard to understand. And I've already checked application code, and it doesn't seem like there's a serializable connection being made from the application side. So I know this is, I don't know if you have any info or it can lead me the right way. I still do need to do a little more research, but was hoping you might have something for me.
Is the application name X, Microsoft X?
No. It's
Okay.
an
Uh,
application.
the same situation is valid for the Microsoft X because we can't change the isolation level. It is in embedded with the application. So I think there is nothing to do. I just advise that update statistics periodically, at least two times a day.
Okay.
It's very important. And, check your indexes, and maybe you have to improve your hardware.
We were low
Okay.
on memory and we upgraded today, and I have to restart something tomorrow morning. But yeah, we're looking at that. It is using entity frameworks. I don't know how the queries are being constructed, but that's more. I know.
Oh, terrible! Really terrible. And
so-
I want to
Thank you.
share you're welcome. I want to share an important information to you. The most important hardware parameter for SQL Server is not CPU count, not CPU speed, or not the RAM size. The most important thing is the RAM bus speed. Please consider this when you upgrade your SQL Server. Please choose the fastest memory speed server. This is the most important thing, and this is related as ratio. For example, you have a memory. The memory speed is 2000 megahertz, and you upgrade it, for example, 5000 megahertz. The difference is about 40%. And you can see the performance with the query result is equal 40%. Older one, the duration is, for example, 60 seconds. The new one, the duration is, for example, it's about 35 seconds. It is near to ratio. So the most important thing about the hardware is RAM bus speed. Please consider it. So I think there's no question. I'm very happy to be here, and
Thank
this
you.
is a very good experience for me. I hope you will like it. You liked it, and nice to meet you for all of you. And have a nice day.
Thank you,
Hey,
Omar.
Omar, one more question about your slides. Some people mentioned that your slides were very good and they were interested in getting a copy of them. Is that something you're willing to share?
So you want my presentation, right?
Presentation slides. Yes.
Sure. I will share with. Let me share. Just a second with Teams chat, and yeah, I think there's a
I'm just-
problem. I will share with you, Eric, Rebecca, and you will share the other people. It doesn't
Yes.
matter.
Perfect.
Yep,
Perfect.
perfect.
Omar, again, it was an honor having you present tonight. Thank you again. I know we took up your early morning, but we hope that you have an awesome day. I guess it's Friday there right now.
Yeah, this is
Thank
Friday,
you.
and
Thank
I will go to work now.
And
And-
hopefully you'll get a chance to come to San Diego.
I hope, and the honor is mine. Thank you. I am very glad to meet you, and see you then next
Thank
time.
you, Omar.
Thanks
Have a
so
great
much.
night.
Bye bye.
Okay, thanks.
Bye.
Bye bye.
Thank you.
Goodbye.